Welcome to the Choose SolidWorks screencast series. My name is Neil Cook, Product Marketing Manager at SolidWorks. Many times when people evaluate 3D CAD applications, they focus on part and drawing creation. However, many of the proven benefits of 3D are realized at the assembly level, where fit and function of an entire system can be tested and costly problems can be identified and resolved. But before you can check for interferences, clearances, or correct mechanism behavior, you have to put the components together properly in the first place. With SolidWorks, this is not only easy to do, but fast and accurate, and with a vast array of advanced mechanical mates, you don't need to find workarounds to get your job done. This can make a big difference to the way you work, and that's what this screencast series is all about. Does it take too long to create assemblies of even the simplest of designs? Is it easy to create complex mechanisms and check if your design works as it should? And do you waste time recreating your assemblies for animations or motion simulations? With SolidWorks, you can significantly reduce the amount of time needed to create highly detailed and accurate assemblies. Create massive assemblies of tens of thousands of components with ease. Create complex mechanisms that can be reused in animations and motion simulations, and be confident that your assemblies are right first time so you can get your designs to manufacturing faster. No other CAD solution offers the power and flexibility of SolidWorks. Finally, assemblies done right. Components are held together with relationships, or mates as they're called in SolidWorks. The simple way to understand how mates work is if you were to describe how two parts fit together. For example, in this transmission model from Baker Drivetrain, these two faces should be coincident. First off, SolidWorks has made an intelligent guess at what sort of mating condition you need. We continue to add mates until the component is fixed, and you can see how quick and easy this process is. To make this process even faster, we can use Smart Mates. Holding down the Alt key while dragging a component will automatically add the correct mate type, which you can of course change if you want. As each mate is added, we can test to see if the component is fixed, or if we want it to be a mechanism, we can check to see if it moves as we expect. Let's continue and finish off assembling these pillow blocks. If the holes we are trying to mate to are misaligned, the Smart Mate icon does not appear, indicating that it's not possible to make that assembly relationship, so it's an easy way to check the accuracy of your components as you go along. Smart Mates can be added to library parts so that reusing them in your assembly is fast and the mates are added automatically. This is a real time saver, especially when adding fasteners from SolidWorks Toolbox. The fasteners from Toolbox snap in place and resize themselves accordingly. Bolts and screws can be resized in length using the Instant 3D on-screen ruler to select the next available size. Selecting the correct size fastener is fast, but you don't need to add the mates manually, so you're saving yourself a lot of work. Though some designs may call for a lot of fasteners, and you certainly don't want to add each one individually. So the last used fastener can be placed as many times as you like, using Smart Mates to speed up the process. If the fastener is added to a hole that is part of a pattern, the rest of the holes can be automatically populated. This again is fast, but also, if the number of holes should change, the number of fasteners will change as well, so your assembly is always up to date. But what about components that are not assembled to a pattern? The Copy with Mates command makes light work of duplicating one or more components to other locations in the assembly, and if they share a common reference, this can be reused, making it even faster. Fasteners are traditionally ignored in 3D CAD because it takes too long to add them all, but they can add significant weight to an assembly and affect the centre of gravity. That's one good reason why SolidWorks puts ease of use above everything else. Different groups of components can be shown on screen using display states as a quick way of isolating areas of interest in your design. The countershaft needs a number of gears and retaining rings assembled to it. Picking an edge whilst using Smart Mates adds two mates simultaneously, concentric and coincident. If we wish to use copies of this component, the Windows standard Control and Drag will add another instance of this component, and we can add smart mates again using an edge. But why do this in 2 steps? Holding both Ctrl and Alt whilst dragging copies the part and adds the mates at the same time. Surely you can't get faster than that. This technique is perfect for when copy with mates cannot be used because there are no common component references. To add the gears onto the shaft, we need to make them all concentric. To reduce the number of mouse clicks, SOLIDWORKS has a multi-mate option where one single common reference can be reused any number of times, and the mates can also be grouped into one single feature, making them easy to edit and easy to organise, especially when building assembly configurations. The gears riding on the bearings need to be positioned between the thrust washers, so we'll add a coincident mate to each one. The Select Other tool allows you to pick hidden geometry when mating faces or edges, so there's no need to rotate the assembly to add the mate. These 2 gears should be free to move along the spline on the shaft, so we just need to position the last 2 gears to complete this part of the design. So far, we've only used the standard mates, but it gives you a good idea of how easy they are to use. For more complex assembly mechanisms like this one, we can make use of the advanced and mechanical mates to complete the job. Let's bring back the rest of the components and assemble the drum so we can check that the gear selector forks work correctly. Assembling the drum onto the bearing allows it to rotate and translate along the bearing axis. But since the pillow blocks are not symmetrical, there's no centre plane to align the drum to. One of the advanced mates, called the width mate, provides the best solution. There's no need to take any measurements so that you can enter an offset dimension or create any mid-plane construction geometry. The drum is aligned perfectly between the 2 pillow blocks and is now only free to rotate. Sometimes the screen can get a bit too busy when you've got a lot of components in your assembly, making it more difficult to see what's going on. You can create another display state or hide the components you're not interested in, but the easiest way is to use the isolate command. This hides all the other components so you can concentrate on the task in hand. To place the fork in the groove on the gear, we could use the width mate again, or a simple coincident mate. When we exit isolate, all the other components return. Assemblies with thousands of components naturally consume more computer resources. SOLIDWORKS has fine-tuned performance of large assemblies, so you don't need a large computer to run it on. Tools such as Selective Open and SpeedPack simplify assemblies by removing unnecessary detail and help to protect intellectual property when working with third parties. We'll look into these and other high-performance features another time. Continuing with the design, we need to make sure that the forks run along the slots in the drum. The path mate enables a point to move along a predefined path. The points can be free to move or fixed at a certain distance or percentage along the path, with full control over the pitch, yaw and roll of the component. This can be used for anything from cams and slots like this, to simulating the path taken by components along a conveyor system, something which would otherwise need to be simulated in an animation and would therefore not give you real-time motion like this. This spring-loaded arm is a cam, so we can use the cam mate to make a cam and follower pair using straightforward selections. A cam mate will allow surfaces to have multiple contact points, but this is not always desirable, so a warning message lets us know there could be a potential problem with our design. Now we can see the full range of motion of the drum, the cam and the forks. There's one last thing missing: gear mates. SOLIDWORKS has mechanical mates that can convert rotary motion to rotation or translation, enabling you to simulate regular gears, bevel gears and worm gears, or rack and pinion and screw drives. Selecting a circular edge or sketch defines the gear ratio, so ideally these gears should have a pitch circle sketch, but this can be easily overridden to get precise meshing of the gears. All of these mates added to the assembly can be reused directly in animation or motion simulations, so you only ever need to set up your assembly once. And there's our completed gearbox. Well, it needs a few more parts yet. I hope you've enjoyed this quick tour of some of the powerful assembly mates in SolidWorks. We strive to deliver simple but effective tools to help you focus on making your designs, not fighting with the CAD tool, and to make it an enjoyable experience too. We want you to look forward to using the product at the start of the day and value its role at the end of the day. For more information and to see other screencasts in this series, please go to www.solidworks.com/choose or contact your local SolidWorks reseller. My name is Neil Cook. Thank you for watching.